So we've mentioned the immune system, and we showed some, very briefly showed some markers in a table, and we've alluded to it through Neiman's J. Well, actually, what are these, and kind of, how do these relate to underperformance syndrome? Well, one of the things that was mentioned in the table were what are called neutrophils. So neutrophils are very much an important component in an innate and kind of intact system. And what's their job? Well, they work in the process of phagocytosis and things like fighting bacterial and viral pathogens and infections, and they are involved in the release of the immunological cytokines. Okay, so they have a role in terms of fighting infection. Very much in the early control of invading infections agents is kind of the immediate effect. One of the things that's often been looked at as a marker is glutamine, and you often hear athletes taking glutamine supplementation. Why? Well, glutamine is an amino acid. Its role is in cell division, and one of the big cell divisions it works is within lymphocytes. So low levels of glutamine have been found in chronically fatigued and underperforming athletes, particularly in things like marathon runners and ultra-marathon runners. So if you've got lower levels of salivary immunoglobulins, you've got reduced what are called natural killer cell activity and changes to the T helper suppressor cell ratios, well, it all contributes to immunosuppression in athletes. So it's kind of like the perfect storm. If you start to become overreached or overtrained, then we start to get decrements in things like glutamine, okay? And again, might partly be explained nutritionally, but it may also be partly explained by that increased energy expenditure, plus other factors, certainly in terms of reduced recovery times. You've now got a reduction in the essential amino acid for cell division. If I can't get cell division, I'm going to get less cells available to fight these pathogens. So in other words, I've got a reduction in things like neutrophils. I've got a reduction now in natural killer cells, which do exactly what it says. They are killer cells. I've got changes in these T cells, which are fundamentally important, again, in helping in the fighting of illness and infection. So all of these kind of come together and reflect what we see in our athletes. So let's think about this in terms of the overall effects of moving a little bit from the immunological. We'll come back to some data in a moment, but just setting the scene. So we can see those immune responses, but how does that relate to performance? Well, what it tells us is, in the data, don't rely on something like lactate, right? This is why it's not as simple as looking at one variable. So here you've got the normal training response. This is data from Asker-Jukendrum. Here you've got the normal training response. Here they've overtrained the athlete, and this is why the taxonomy is important. They've deliberately overtrained them, right? This isn't an underperforming athlete in terms of a true definition. They've just made them train much harder over this kind of 2-week period. But what you see is the blood lactate concentration at a fixed workload decreases. And it decreases for a number of reasons, partly to do with suppression of things like the catecholamines. It's almost certainly affected by the fact that you're pushing an athlete into that red S zone. They've got less muscle glycogen. If I've got less muscle glycogen, my ability to produce lactate is diminished. We come out of that training block, we taper the athlete, so now what we're getting is supercompensation, and guess what? The lactate concentration increases. So you have to be very careful in looking at just lactate. And in fact, if you look at the blood lactate profile to exercise intensity, as we would expect to see, for example, in endurance athletes, when we're kind of tracking endurance athletes over X number of weeks, and we look at the blood lactate profile, what you can see is, again, here's your kind of trained athlete, here's what they've got in the overtrained athlete. Well, your interpretation is, that looks like an improvement submaximally. They've got lower concentrations for the same relative workload. But the telling point is they can't produce as much lactate. And we don't rely on peak blood lactate scores. But you can easily misinterpret that. But the key thing to understand is it's almost certainly a reflection of being in that red S zone. They've got less glycogen, because they've got less glycogen, and they've got the suppression in terms of, as I say, things like the catecholamines, the net result is you get lowered concentration for the same workload. It's actually a reflection of the athlete being on that spectrum, being in that overreached state, probably functionally overreached at this point, but being overreached and moving on that spectrum of towards underperformance. Cortisol was mentioned earlier on. Well, cortisol is absolutely a hormone that shows us stress, and so you would argue that if the athlete is in a period of training and they are stressed because of the volume of training and the amount of recovery, you'd expect to see that cortisol increases. Well, you can also record this pre to post exercise, the acute response. But notice something. If you look at this data set here, look at how variable the cortisol response is. In fact, you've got one athlete here whose cortisol concentration decreased. Most athletes, it increased, some quite significantly, some with only kind of marginal changes. But it's highly variable. And the thing to recognize is that cortisol does not show you the distinction between what is biological and what is an emotional reaction. And if we're trying to understand in our athletes, and we're trying to understand what is causing underperformance, remember we're trying to get rid of the word unexplained so we can explain this. We need to be able to differentiate what is emotional, so the kind of the outside influences that we saw in that statement from the European College of Sports Sciences, from what is actually just a reflection of just the amount of training that they're doing. And so that is where some of the data that you see here starts to come into play. So yes, we could look quite simply at the cortisol concentration. Now, if you look here, it's quite interesting. So here's the normal training response, which is a nanometer response of about 430 nanometers to 471. It's not considered to be a significant change. It's increased, but not significantly. So what actually people have started to look at, they've not reported it here, is actually the cortisol to testosterone ratio. Because the testosterone actually reflects the changes in terms of stress that's being placed on the muscle. Remember, it's an anabolic-based hormone. And so actually, if that ratio from cortisol to testosterone shows that kind of a positive response, then fundamentally you've got an athlete who's showing a stress as a reflection of the training rather than necessarily just an emotional response. If we look at something like plasma glutamine, look at the change here. Glutamine, again, when we train an athlete, glutamine concentration decreases. It may simply be because they're in the red S zone. It may simply just be a reflection of a greater energy expenditure to energy intake. But nonetheless, glutamine concentration does decrease. Remember that we said glutamine is fundamentally important in things like cell division. If we then look at the changes in things like the immunoglobulins, which is our IgG and IgM concentrations down here, remember that this is what Niemann was suggesting becomes your markers of immunological responses. Look at the changes. Okay, they've got lower concentration. Remember that Niemann showed that when you go into an intensified period of training, they drop off a cliff. And you can see in both IgG and IgM, just different variants of the immunoglobulins, both show significant decrements. Almost certainly a reflection of what Budget was talking about, which is as soon as you apply a stress, you basically create a suppression in terms of the immune response because of fatigue. It's exactly what Sale was talking about in his alarm reaction hypothesis. And again, slight decrease in the natural salivary immunoglobulins here. But if we look at plasma creatine kinase, and this is our indication of muscle damage, this is our indication that there has been a training effect. So this can be viewed both positively and negatively. On its own, as an acute response, well, that indicates training stress. But when you start to take into account with the other variables, then we start to see that actually it might be more complicated. That if this carries on, if the creatine kinase concentration doesn't reset, and these don't reset, then it's an indication that we haven't got an athlete who's recovered. And if we don't allow for that recovery, the athlete is then going to move down that spectrum of response in terms of moving from functional to non-functional overreaching to burnout and potentially to underperformance syndrome. Now, we've got a really nice data set here which will perhaps help us explain this a little bit more. So here we've got glutamine concentration, and we've also got histidine. So this is two amino acids. And what we've got in this study are 3 training groups. And what we've got is in our 3 training groups, they've got athletes who have got with infection and without infection. So it's quite a complex construction that we've got. So 3 groups. Group A are athletes who just report no symptoms of fatigue at all, right? Group B, they feel unwell, or they don't feel particularly well. But Group B, athletes who feel well but have actually got symptoms of fatigue. And then Group C, these are the athletes who really just haven't been able to train for either being too fatigued or feeling unwell. And what do you notice? Well, you notice if you look at glutamine, if we look at, if we take our glutamine concentration and look at the without infection athletes here. So even when they've kind of got no natural infection, look at the change. Look at the change in the glutamine concentration from the athletes who've got no kind of symptomology to the athletes who are really, really struggling. Quite significant. And that's the ones with the kind of the classic infection. So these are individuals who show no symptoms. They're training normally. They've got no symptoms, no fatigue, no illness. But look at the glutamine concentration, much, much higher. And as we move down that spectrum of response, we're moving from not recognizing it, starting to feel some symptoms, to actually having significant manifestation. Look at this change in the glutamine concentration. You see the same, near as damn it, in the histidine concentration. There's a bit more variability going on here within this group. Okay, but if you've got with infection, again, a little bit more variability in terms of what is going on, but with the infection group, again, highly variable in kind of group C, but you can see the same thing when we've got this one athlete in group B here. So we can't draw an enormous conclusion here when we're looking at, say, glutamine from these 2 groups, but it's the without infection group. These are the individuals. They aren't having symptoms of infection, but look at the change. Now, if we now go a stage further and take our glutamine concentration, and we've got our 3 groups, A, B, and C. Remember, Group A, no symptomology. Group B are reporting some symptomology, but are still kind of training. And Group C have got the symptomology and fundamentally aren't able to train. And then what we've got is we've got 3 time points. So we've got almost like pre to post, which is going from 1 to 2. So 1 to 2 is kind of moving from a period of training, and what you can see here in our glutamine, this is our Group A. Remember, no symptomology. If we take our without infection kind of group, we've got 2 athletes here, but fundamentally what you see is glutamine concentration increases. So it responds positively to training. If we go to Group B, so here's kind of our normal training period. Remember, these individuals are the individuals that kind of have some symptomology but are still training. Without infection, our without infection group are actually getting the increase in the glutamine over the training period. But then what they've done is they've then exposed them for a 3-week period where they've given them protein. And actually what you see is there's only kind of a couple of cases of this, irrespective of whether they've got infection or not got infection, we see an increase in the glutamine concentration. So suggesting actually an increase in protein, remember you need proteins to drive amino acid production, actually may be beneficial. And then if you go to Group C, remember these are the athletes who have got the symptomology, not been able to train, and then they've recorded them over this same time period, this 7 to 8 months, and then the additional 3 weeks. And what you can see here, you've got a lot that have got kind of infection, highly variable in terms of what we're seeing, but you've seen changes in glutamine concentration over that period. Remember, they're not training in this period, not training. So because they're not training, what we're seeing is glutamine concentrations are increasing. Remember, we've taken that training stress away. But when they give them the protein on top of this, look at the significant effect. So it's showing that actually there is a nutritional implication here, but perhaps not what one thinks. It's not about kind of energy expenditure. It's actually about having protein that's going to enable us to kind of resynthesize something like glutamine, which is needed in terms of cell division and cell production.